I'm Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this video, we'll discuss about partial fractions and look into techniques to find partial fractions of rational functions. This video is of prime importance for students in UK following Edexcel program or equivalent, AP program in US, and the Ontario curriculum in Canada. Those who want to learn from me, they can always send an email on the address given here. I am conducting online classes using Zoom these days. Now let's talk about partial fractions. What are they after all? Well, we have rational expressions. These rational expressions can be decomposed and written in a very simplified form, and that is what we call partial fractions. So, in short, decomposition of rational expressions as sum of simple rational functions is partial fractions. Now, when I say simple, it means what? I hope you're reminded of fractions. When we simplify fractions, we like to write them in the lowest terms. Normally, we will write fractions as proper fractions. That is to say, that the numerator is smaller than the denominator. Now, when we talk about rational functions, in that case, we know that a rational function, let us say r of x, is basically a ratio of two polynomials, so which has a numerator and a denominator, right? And of course, the denominator is not equal to 0. That leads to the restrictions. Now, in this case, the degree of numerator should be smaller than the degree of denominator, right? So when we say simple fractions, when we say simple rational expressions, it means what? It basically means that the degree of, let me write down here, numerator is less than degree of denominator. Is that clear? So that is the simplified form. Well, not only that, what we also do is we split the rational function into sum of rational functions so that we have only one factor or a zero representing the denominator, right? So that's what is a simplified form. So in this process, what we will learn is that we could write a rational function with a constant in numerator and a linear factor in denominator in a simplified form. It means something like this. If I have 5, which is a constant, divided by these are the two linear factors, we could write this as a over x minus 4, which is one of the factors, and a constant b over the other factor. So that is what partial fractions are, right? And we call this process as partial factorization, right? Now, if you have linear term in the numerator as shown here, 2x plus 1, and of course a combination of linear factors in the denominator, even then we could write it as sum of two rational terms, a being constant with one of the factor x plus 5 in the denominator, b being constant and x plus 2 as the other factor. Sum of these two. That is what we want to emphasize on when we say partial fractions, right? Now, in this case, we could have a special case when the denominator has repeated factors, right? So repeated factors means we have multiple zeros at a point, right? So in this given example, x minus 1 whole square represents that at x we could have two zeros, right? X equals to 1 will give us multiplicity or order of 0 as 2. So that is what we call as repeated factors, right? So x minus 1 times x minus 1. If that is the case, in that case, if there are basically three factors in the denominator, right? X, x minus 1, and x minus 1. So we get three terms with constants a, b, c in the numerator, and the denominator being the factors x, x minus 1, and x minus 1 whole square. You get the idea. So we will now see how do we do this process. I look into two different ways of doing it. In example 1, which is a straightforward example, the question here is we need to do partial factor with linear factors in the denominator. The two are x minus 4 and x plus 1. The numerator, as you can see here, is a constant 5. Well, this can be written as a over x minus 4 plus b over x minus 1. Now the steps involved are, first step always, when you have rational functions, the best thing is to get rid of the denominator. So what we do here is that we have a common denominator, which is x minus 4 times x plus 1. So step number 1 is multiply both sides by the common denominator to get rid of the denominator. So what I'm trying to say is the whole fraction with the rational expression, rather the equation. So the whole rational equation will be multiplied both sides by the common factor, which is x minus 4 times x plus 1, correct? So when you do so, on the left hand side, we get only 5. Do you see that? So as you can see here, on the left hand side, you get 5. And on the right hand side, a gets multiplied by x plus 1 and b gets multiplied by x minus 4, right? Cross multiply, correct? So we get an equation which is represented as 5 equals to a times x plus 1 plus b times x minus 4 in this particular case, correct? So once you do that, this is what you get. A very simple equation to solve. Now in this particular equation, we have two unknowns. We need to find the value of a and b. The best technique is to make one of the factor as 0. You get the idea. So we'll call this as our method 1. So we have two different ways of doing it. So I'm just calling this as method 1. In this method, we are selecting values of x so that the factor, one of the factor, becomes 0. You get the idea, right? So the idea here is, first step, as we say, times common factor, right? Times common denominator. And second thing is, we'll try to put x equals to a value, let's say x1, so that a factor x minus x1 is equal to 0. You get the idea. So that is the whole idea. So what we have done here is that we have put x equals to 4. Now if I do that, then b is x minus 4. That will become 0. Do you see that? So as soon as you substitute x equals to 4, the term, which is the coefficient of b, will now be 0. So this term will be 0, and we'll straight away get the value of a, right? Since x is 4, substituting, we get 5 equals to a times 4 plus 1 plus 0, right? Now 4 plus 1 is 5, and therefore 5 equals to 5a means a is equal to 1. So we now found the value of a. You see that? So now we got the value of a. To find the value of b, what are we going to do? Now at this time, we will make the other factor as 0, which is x plus 1. For that, I'm going to substitute x equals to minus 1. As soon as I do that, you see this factor, a times minus 1 plus 1, that is 0. So we got the value of b. So b is minus 1 minus 4, that's the coefficient, and that is equal to 5. So 5 is equal to minus 5b, or b is minus 1. So we got the value of b also. Substituting the values of a and b in the equation, we get partial factors for the rational function 5 over x minus 4 times x plus 1. So I hope this is absolutely clear, right? Now here is another method which we can adopt. So first step is same. I'm calling this as method 2. The first step is same, which is multiply both sides by the common denominator to get rid of the denominator, right? And then we'll expand and simplify and compare coefficients. So there's something slightly different. So what we'll do here is once we multiply, that is to say, as we did earlier, we'll multiply both sides by the common denominator, which is x minus 4 times x plus 1 in this case. In that case, we get in the left hand side 5 and on the right hand side a times x plus 1 plus b times x minus 4 as we got last time, right? Earlier. But now the idea here is the step which is different is to expand and simplify and then compare the coefficients. So we'll expand and simplify, that is to say apply distributive property, right? So when you apply distributive property, what do you get? You get 5 equals to ax plus a, which is when you multiply a with x plus 1, and when you multiply b with x minus 4, you get bx minus 4b. Now that is equal to 5. So at this stage, what we see is that on the left side, we have only a constant, right? And on the right side, we have two parts, constant and the variable. So let's factor out x and we get a plus b. Now clearly, this a plus b should be equal to 0 since on the left side we only have a constant. And that constant should be equal to what? Well, this constant should be equal to the constant term a minus 4b. So we equated 5 equals to a minus 4b and 0 equals to a plus b. So with that we get two equations. You can solve these simultaneous equations to get the value of a and b. In this case, fairly simple. Or we can actually subtract one equation from the other, and if you do so, you get the value of b since a and a gets cancelled, right? So 5b equals to minus 5, and that implies that b is equal to minus 1. Now from the second equation, we get a equals to minus b, right? So a is minus b. Since we know that b is minus 1, we'll substitute this value here to get our answer, which is a equals to 1. Now we know that a equals to 1 and b equals to minus 1. Substituting, we get the result, which is 5 over x minus 4 times x plus 1 is indeed 1 over x minus 4 minus 1 over x plus 1. Is that clear to you? So we get the same result, but these are the two ways of doing it. Perfect. We'll adopt method 1 in most of the cases. Now let's look into this second example. Now in this particular example, in the numerator, we have a linear term, not a constant as we had last time. So this time we have a linear term. We'll follow the same method. That is to say, we'll multiply both sides by the common denominator. So on the left side, we have a linear term, 2x plus 1 in this particular case. On the right side, a times x plus 2 plus b times x plus 5. Correct? We have this term. Now again, we will try to substitute the values of x. We'll apply method 1, right? So now we'll do method 1. You could do either method, right? But we'll continue with method 1, which is substituting the values of x and then finding the constants. So the idea here is that we'll substitute x equals to minus 2. Do you see that? So if I substitute x equals to minus 2, coefficient of a becomes 0 and we can directly find the value of b. So that is what is done. We'll substitute x equals to minus 2 and so we get b equals to b times minus 2 plus 5, which is 3, and so we can find the value of b, left side being minus 3, coefficient of b is 3, so the b value is minus 1. So we get our answer. Do you see that? So have a close look at it. Try to understand the process. Straightforward. You can adopt the second method just to practice and check your result. Okay. So let me say here that for students' activity, try method 2 and confirm the result. Is that clear to you? Very similar examples, first and second. Oh, only difference being that the numerator has a linear term. Well, now let's make the other term as 0, substituting x equals to minus 5. That takes care of b, which is b times x plus 5 minus 5 makes it 0. So now we can find the value of a, right? So finding the value of a, solving a gives us 1. Substitute a and b value, correct? And then write down your answer. Is that clear to you, right? So we get both the values, b as minus 1, right? And a as plus 1. That gives you the partial factorization of 2x plus 1 divided by x plus 5 times x plus 2. So I hope this step is absolutely clear. Let's move on and take the third example. This is the last example of this video. Now here, what we have is that we have to partial factor with linear factor in the numerator and denominator, but there is one difference, and that is that we have repeated term here, right? X minus 1 whole square, right? So we have a repeated term here. So we say as a repeated factor in denominator, right? So that becomes our third case in the third example. So we have a repeated factor. So in this case, it is x minus 1 whole square, right? So that is a repeated factor. So that will result into 3 terms instead of 2. You get the idea, right? So because this x times x minus 1 times x minus 1. The constants now are a, b, and c. However, the method is same. So we'll again adopt the first method, which is we'll multiply both sides by the common denominator. In this case, it is x times x minus 1 whole square. So that will get rid of the denominator. So we'll get an equation to solve. The equation here is 2x plus 1 being on the left side, and on the right side, a gets multiplied with x minus 1 whole square, b gets multiplied with x and x minus 1, right? And c gets multiplied with x. So we get this particular equation. Now to solve this equation, as you can see at this stage, it is better to substitute and get the results, right? So one by one, we'll make the factors 0 to find the result. However, we have two only values to put in. One is x equals to 0, the other one is x equals to 1, correct? So if I substitute x equals to 0, in that case, both these terms will be 0, right? Because they are bx and cx, will make it 0. We get the value of a. So that gives us the value of a. We find that the value of a is 1. Is that clear to you? Simple as that. Very easy. Now we can substitute x equals to 1. In that case, x equals to 1 will actually take care of the first two terms, and we can find the value of c, right? So we have now the value of a and c, a being 1, correct? And c being 3. We need to find the value of b. What should we do? Well, third term, we have to substitute some value for x. So we chose 2, right? 2 or any convenient or any other value. Any value you feel like. Of course, you should minimize your calculations. Perfect. So I substituted 2 and I know what a is, right? So and what c is. So I'm substituting the value of a as 1 and of c as 3 in the equation. So the only unknown in this equation is b, correct? So we can find now the value of b from this particular equation, since a and c are known to us. So you could choose any value. We chose 2. That's okay. You could choose any value, but not 0 and 1, right? You could choose minus 1, for example. That could be a nice value. Okay. Then you solve for b's, that is the only unknown. So we get the value of b also, which in this case is minus 1. And substitute a, b, and c. That minus 1 is being reflected here, right? Minus 1. And so you get partial factorization of this rational function also, correct? So these are the steps involved. So we have seen that how do we perform this activity of partial factorization in rational functions. So the idea here is to decompose the rational expression as sum of simple rational functions. Simple really means that the degree of numerator is lesser. In our case, numerator is constant since the factors were linear, right? So whenever we have linear denominator, we'll always have the numerator as a constant, 1 degree lower. While if it is a repeated factor, even then it is a constant as we saw here. You get the idea, right? So even if it is a repeated factor, it is a constant. Perfect. So we did these three examples. One where there was a constant term in the numerator, another one with a linear term, and then we took an example where there was a repeated factor in the denominator. Perfect. So that is how we could do it. I hope the steps are absolutely clear. Feel free to write a comment, share your views, and if you like and subscribe my videos, that'd be great. And if you want to study from me, you can always send an email on the address given here. Thanks for your time and all the best.